This is the Matlab project done by Evan Wolfson and Siwoo Lee, and it is a collection of, it's just a collection of a bunch of equations in a Matlab file, so that you can run through a couple of equations, and it really just stores them all so you can do it whenever you want. We have the quadratic equation, the cross product, the dot product, and also a plotter for trajectory, just simple 2D trajectory with initial velocity, initial vertical distance, and influence of gravity. And basically how it works, it's all pretty simple. They all pretty much work the same. I'll just go over the quadratic equation in the flowchart. So it starts off, you run the Matlab project, suitably named Matlab project, and it'll prompt you with a set of 5 options, which you can enter in 1 through 5 to get either this equation, cross product, dot product, trajectory, or you can just quit out of it. Say if you entered 1, you get the quadratic equation, so to display the quadratic equation along with variables. It would prompt you to input several variables, or you can enter in back as a script, and it'll take you all the way back to the very beginning, so you can choose some other equation. And once you're in once you have the equation you desire and you enter all the variables, the script will take the information, run it through a function, which will give you your final values, then it'll display it to you in Matlab. So here's the actual demonstration of it. So it's just called Matlab Project 1. So here's the main screen. So as you can see, 1 for quadratic, 2 for cross product, 3 for dot product, 4 for the trajectory, and 5 just to exit the program. And 5 just does just that. And it's kind of a lengthy name. Okay, so say we want the quadratic formula. And so it'll just take you to this screen, it'll prompt you that you can go back to the initial, or the invoking script, and it'll also give you this. So say you wanted to go back, you just type back, and you can do that with each and every one. So for this one, you can freeze it if you really want to see what it says. So and then 3, and finally 4. So you can do that in every single one. So let's go through the quadratic really quick. So let's say, let's just give it simple values like 1, 2, and 1. And as you can see, it just prompts you for each and every one. And once you enter in all 3 values, it'll clear the screen and give you both the roots. So let's try a different equation. I'm going to copy this really quick just so it's a little bit easier to enter in. Cross product is pretty simple as well. Just enter in everything as it prompts you, and it'll give you the x, y, and z, and it'll tell you how they fit into the vector. Same with the dot product, except it's a little bit different. It'll tell you vector A, and then switch over to vector B right afterwards, and give you the scalar product. For the 2D trajectory, this one's probably the most complex one we have. This one, when you enter in all the information, it gives you back a plot that is, I should say formatted so that the boundaries on the graph are between well, first of all, it's plotted with the vertical height versus time. So the x-axis is time, and it'll give you boundaries from your minimum time value to your maximum time value, and your y-axis will be from 0 to your maximum height. And so d underscore 0 is your initial distance, let's say that's, or your initial vertical distance, let's say that's like 100. V underscore 0 is your initial velocity, let's make that 50. And then it'll ask you where the time boundary is. So let's say it's -10 to 10. So that'll, according to the equation, show you a little bit before time 0 and a little bit after. When we hit enter, it'll run it through the function and give you back a plot. And there we are. So it goes from -10 to 10, and from 0 to the maximum, which is probably around 240 or 230. And that's pretty much all this thing does. Like, it's variable, so if we run it again, and we entered in different values like 300, I don't know, 560, just some random stuff. And then it'll give us a different value and different dimensions and everything. So I'm actually going to take you through the scripts and everything, just show you a little bit of how it works. So here's the main script. It has all the annotations and everything, so you can read through it as you will. So it displays all the options and then has a if statement to determine which one you want. So if you enter in, 1, 2, 3, or 4, it'll hold that in this variable a, and then after that it'll run whichever one you desire. And the very end, if anything else than anything other than the 1 through 5 are selected, it will tell you to basically get your stuff together and select the correct variable. Here's the quadratic script. It just runs through all displays and then input values, and then runs the function, which is right here. And it's pretty simple. It's just the positive bound and the negative bound. And then it'll plug it back in there, and as you saw, it'll give you the positive and negative answers. For cross product, it's also pretty simple. Just input everything in the script, and the function does all the work. For the dot product, once again, just inputs everything, and then the function gives you all the work. For trajectory, it's a little more complex because we have more variables as well as a plot to worry about. So it starts off, you input the initial position and initial velocity, and also the time boundaries, and then it will run it through this function, which separates it into, well, it takes your final t-value or initial t-value and breaks that up into 100 different, you could say tick marks, so like just sections, and then it'll set this variable n equal to the minimum bound to the greater bound with this dn as the spacing for it. And then it uses a loop from 1 to the length of this, so I guess 101, and it runs y through every single one of those to get our graph. And right before it ends and outputs all the data, it finds the maxima of y, so we can get our upper bound for the vertical distance. And then it runs it back through the script after this, and it plots everything and labels the graphs and the axes and everything. And that's pretty much it. I think I went over everything, so thank you for listening.